Anyways, so once again, hi everyone. So back here with you all, and hi to our audience. I know it's a short notice, and we just put it out there. So today's topic is we're going to be covering evidence grounded AI for clinical research and intelligence. And just before we go there, I just want to give you guys a quick introduction. I have Nikhil Brahmanandan here, who's been an intern and also working with us for some time now. And I know Nikhil for some time personally. So, and he's going to be sharing all his amazing knowledge and things. He's pulled together some good use case. He's been working on this project for, I think, over a couple of months. And I'm sure through his learnings as an AI student, that's what he would like to call himself humbly. And, he's going to be sharing his side of the story. We're looking forward to hearing more on that front. I'm excited about this personally because when I studied about these topics, I'm a finance, consultant. I work in large SAP engagements, and when I dive deeper into AI and start to learn how the computer system, the large computer systems, then power up this AI related use cases. So that's where I was kind of hoping to see some of this happen live, like the concept around RAG. Then furthering down into the evidence-based RAG, which help us connect, like so that the user can validate whether the system is hallucinating or is it telling the facts, right? But it's an obvious thing for the user to kind of go and validate what the source of the information that they're getting, where it's coming from, especially in the case of, say, for example, medical field, right? We cannot have some results which are not backed by evidence. That's kind of the logical thinking for me as a finance person, and also more on the business side of the house. But anyways, I'm looking forward to hearing from Nikhil, and he's going to share his amazing knowledge there. We have Kia here. She's our full stack developer. She's, just to remind you all, she's the she, Khushbu, Sangmitra, some of the team members who help pull together the website, and they're doing much more than that, right? So thanks, Kia, for being here. Thanks, Nikhil, for being here. And then
It's a
we
pleasure, Ashish.
Great, great. Amazing. And then we have Karthik here who helps us in multiple areas. He's also a PMO analyst who was also part of one of our key projects at the client side. Anyways, so without further ado, I will start presenting and I'll pass it back to Nikhil so he can start sharing the background of the project and additional details. Yeah, so Nikhil, over to you.
Yeah, hi everyone. I'm Nikhil Krishna. I'm a student at Stevens Institute of Technology. I'm currently pursuing my master's in applied artificial intelligence, and it's been wonderful experience for me working with chatbots. And let's dive into before I dive into all these evidence grounding, AI, clinical research intelligence, and all this. I would like to start off by saying that for people like me, right, people who grew up watching all these sci-fi movies, I think the idea for us was that what made it cool was these things never went wrong. Us able to being imagine a machine that almost never went wrong. And now we are at a point of time where we can make it a reality. And not just as a fantasy, because I think it's the need of the hour for the industry. That is where I feel like this project personally means a lot to me. Uh, so the idea is we see these sci-fi movies and there are all kinds of AI in them, right? But what we never see them going wrong. I think that's the need of the hour again. So this is what the project is about. The project is about making an trustable AI for the clinical research intelligence, where the data from the clinical trials is used for making decision, not just assisting decision making, but to make sure that the making process is trustworthy. And there are many layers to this as well, I would say. Like there is the of course the fact of getting the data in, making sure that we are not uh, we are following with the compliance of the law, compliance things, and making sure that these systems are ready for production. Because it is one thing to theoretically think about these systems, and it's a completely different ball game for us to be able to put these systems into production. Uh, can we go to the next slide? Yeah. So this is the industry shift that I feel like that's going on right now in the AI space, right? Like we had the GPT era. I think it's reaching its plateau now. Like, okay, for us now, generating answers is not something cool. We are accustomed to it at this point. The next wave of AI is where we actually prove that, okay, these generated answers are good enough to be put to test. I think that's a sort of a gray line that many people have, and that's a thing that people are hesitant when it comes to AI. And I'm pretty sure even Ashish, Kea, and Karthik would have some thoughts on this.
Yeah, I think
Yeah,
yeah, go ahead, Kaya.
yeah, no, Nikhil, you are right. Like, there are a lot of people who are like dependent on AI in getting information. So we have to make sure that it's coming from a verified source because like there are so many sources online, you never know which ones like you can trust and which ones you cannot. So yeah.
Yeah, this totally makes sense because, we need to be able to validate like what is like where the source of the information is, and for a user to be able to say like, hey, like this is the result that the computer system gave, and if it is giving us the right result or not, right? So I think this totally makes sense.
Yeah, and it makes sense from a trust part, but even in heavily regulated domains like the medical domain, right? A fluent answer that cannot be audited is not a feature. That's a compliance risk for the industry. That is a big red button for the industry to step away from the product, right? And that is the core philosophy of Project Apollo. Can we move to the next slide?
So Nikhil, sir, yeah, I just have a question. So what inspired you to name it Project Apollo? Is there a meaning behind it?
Yeah, so I am a huge fan of Greek mythology. I've read the Percy Jackson series books. I've played a lot of video games like Hades and all. And for me, when I think about health, that's a mental image that I conjure up. You know, this Greek god with his staff and his two serpents winding around it. So that's the first name I came up with, and that's what I have stuck to since.
That's cool.
Nice. It's a complex one, and it also resonates with the moon mission, I guess. So I don't know. I was thinking it
Yeah,
was connected to that, but okay.
yeah. Right. So as a AI student also, right, I see a lot of people doing medical projects in AI, but they never come to fruition, right? Because the huge illusion of looking correct is what is stopping AI from actually being deployed in production systems. Like even a very small error can become a very major issue downstream, and looks correct is never good enough in the field of medicine, right? Because in many cases it can mean the matter of life and death. So this is why the clinical research is extremely uh, averse of using AI in their uh, day-to-day practices. So this is the main fragmentation problem that we are trying to solve here. uh, can we go to the next slide?
So one question, Nikhil, is like, we have, say, for example, we have the evidence that's kind of showing the user that way we got that result from. Uh, However, like there's still the computer could still give a wrong result, right? So basically, you are saying like because the user can see from where the system has calculated all these things, so they can make a decision whether that's accurate or not. But then also there's like so much humongous amount of data out there that the system may be going through to kind of analyze this clinical trials, etc. So can you help me connect the dots there? Like how does that come together?
Yeah, so this data is not in a very streamlined format, right? Because the US decides to store data with its own compliance rules. The European Union decides to store data with their own compliance rules. And we go to India, we have different kind of compliance rules. So the idea is to make a structural single coherent corpus, right? And it's not just about telling the user where it got the data from. It's about actually specifying which exact line of the data that it got the assumptions from. I think that is that level of microscopic detail is what we are looking at here.
Okay. So it's also standardizing the data. Are you saying we have to standardize the underlying data also in a way?
Yes, because even across all these different kinds of compliance issues, there is something that can come out of it, and that is the end data. The way of presenting it and maybe the way that the data is being accessed may change, but the underlying data itself doesn't change. The underlying data itself is still the same. So this is what the main problem is for right now for using the AI in clinical or medical field, because
Got it.
I see a lot of academic projects not translating into real life projects, and one of the one of the most common issues that I hear is this part.
Got it. Got it. No, that makes sense. So yeah, it seems like because all computer systems and applications are different, so standardizing definitely makes sense. So we can go to the next one if you want to.
Yeah, we can. Yeah, this is what I am saying, right? Because most RAG demos they work on paper, they work the demo systems like they may be taking things that are adjacent, not actually useful information, but okay, it's close enough, or the answers are very fluid and authoritative sounding. I'll get back to this point more later, but this is actually one of the drawbacks I feel. And there, and the third part is what I was saying when I mean microscopic level of detail, right? Most RAG demos only do document level citations, but reviewers cannot actually verify what was actually retrieved from the document. So one specific claim from a document should go in depth into where from the document the data has been pulled out of. And the fourth part is always the production system and the scaling part of it.
Wow.
So uh, yeah, I think we can go to the next slide. Yeah, so this is the crux of Project Apollo, right? We build a clinical evidence intelligence layer. This the whole and sole purpose of this system is to give us grounded answer, like every response is grounded to a retrieved evidence, not generated from prior models or some chain of thought, directly deriving from the documents itself, and it is built around citing everything. Like in academic papers, we see if something from somewhere else was used, it's explicitly cited so in the citations part. And the focus here is on the trust part of it because it cannot be a black box machine anymore. Like maybe couple of years back, people used to think of AI like this black box machines, but now we need to focus on making these traceable and human compatible systems first, not as afterthoughts, but as the priorities of the systems.
Yeah, I think
I,
this totally resonates with the finance also, Nikhil, because I think for any system for that matter, like in the enterprise space, right? So because any decision we are making based on the computer system results, it can cost dollars to the company, and obviously every organization wants to be sure about the decisions that are being made. So I think this concept is very much applicable to finance world, supply chain, manufacturing, all the different areas, because there is a bit of a like race towards, hey, let's implement AI, but the AI is not for the
yeah,
sake of AI, but it's like, hey,
yeah,
for actually deriving business outcomes, right? So like
yes.
when I'm giving a CFO a presentation on the financials, how validated and what is the source of that info to the line item level, that's where I think this concept is really powerful, that we can apply this to.
Yes, Ashish, because I think we've come to a point where AI stops being, hey, this is a cool thing we have, to okay, but where is actually my return on investment, right? I think we are past that experimentation phase, and right now the need of the hour is to build viable products using AI.
Yeah, makes sense. So we can go to the next one, Nikhil.
Uh,
Yeah,
I have a question for
y-
Nikhil, Ashish. I mean,
Sure.
yeah, yeah.
so Nikhil, the first pointer on the slide you mentioned this project Apollo as a clinical evidence intelligence layer, right? So just to be clear for even for the audience, so this is not a proper chatbot, right?
No, no, no. A chatbot is it's a very oversimplified way of like a chatbot is the end user experience. Like that's how they communicate with the Project Apollo. But
Mm-hmm.
the underlying system itself is a retrieval augmented generation system. Like it's a rack system, right? So
Okay.
fundamentally, chatbot is one of its capabilities, but that's not the whole picture. People
Okay.
can, see discrepancies in the kind of data that they're pulling. They can validate the kind of data they're putting in, and any kind of missing data comes up. That's also very transparent.
Got it. Got it. Thanks.
Yeah.
Yeah, actually, like it, I was also looking at like what Databricks has, and Saranya was telling about that. And I was looking at actually the system. It's able to kind of have that history of where this information is traveling from. But I think it's kind of making sense from that standpoint also. What you are saying, and it's more than just the front end, but the back end systems. So what's cool is I believe you built the demo also, Nikhil, which maybe in the next session when we are ready, we can show that at some point. But
Yeah.
yeah, should I go to the next one, Nikhil, here, or you want to cover additional?
No, I think we can go to the next one. Right. I mean, we can just flip this slide. I've been talking a lot about these things, so yeah, yeah, and this is again a very interesting point to note, right? A lot of people think that a good product is a product that always answers, but for me, I like to think a little differently, right? We do not have sufficient evidence. I think it's better to say that we do not have sufficient evidence rather than to give out completely wrong information. I think that is where the trust factor is missing with a lot of AI products these days. So this is if I had to, build a system, I would rather build a system that fails correctly than a system that, fails silently from
Yeah.
an engineering standpoint.
Makes sense, Nikhil. It's a zero trust kind of a situation to make sure we can, kind of tell
Yeah.
the answer where it's coming from. But also, like when I was doing the MIT course, which was about 2 years back when GPT was launched around that time. So
Hmm.
my there was a lot of concepts we learned. We talked about probabilistic predictability, etc. There were some concepts around that. Then we also
Hmm.
learned some of the models, right? Like we talked about like random forester model, which was, and then there was like this math related like linear equations, etc. So there were like different kind of concepts that were coming together, which were
Hmm.
getting applied into the computer applications and or maybe stitched together in order for us to be able to predict a certain use case, right? Now,
Yes.
where I get thrown off a little bit because it start to become a bit of a gray area in terms of how the computer system is deciding certain things, right? Even though like you're able to connect the dots from the standpoint of, hey, these are the places I retrieve the information from, and this is how I'm giving it a result. But say, for example, if I want to know, hey, how does the random forester model work? Or if I put that into my logic, right? Then how do you
Mhm.
kind of break that down for a user?
So I think this is a very interesting question. This is a very interesting point of discussion, Ashish, because you mentioned these methods like random forests and the linear methods, like the methods like linear regression and all, right? So I think as the complexity of the model increases, right? Let's say we have a simple regression model, and then we slowly scale it to a decision tree, and then we slowly scale it to a transformer, right? In the process, the complexity and the performance of the model, like the performance increases, but what drops drastically is that the explainability of the model decreases. I would say,
Mm.
like
Yeah.
the ability to fundamentally say, hey, this is how the model reasoned this answer, becomes harder and harder to figure out. And I think that's where a lot of these uh, black box discussions come around, and that is a very exciting area of research that hopefully, we go work towards.
Okay. Okay. Yeah, it's not a very straightforward answer, but definitely maybe for a further discussion, as we dive into it.
Yeah.
Okay.
Uh, any other thoughts, guys?
I think it was interesting, Nikhil. I'm just thinking that if, like, how will it crawl into internal systems? Will it need any additional access?
Right. So this is the mode of the trickier part of the system, I would say, because evidence, there are hundreds of thousands of documents, right? But while that is one problem, another big problem is that, okay, but should we really trust an AI with our medical data is a very valid question that people have. And and it is something that even and from a development standpoint that needs to be taken seriously, because the data itself should be secure enough so that the AI only uses data it needs, and after the work is done, it does not store them in any capacity. I think the user should have complete control over that. That is a non-negotiable, in my opinion. It's a non-negotiable thing. I think that's where a lot of compliance issues arise from, because the data is not handled properly.
Yeah, and also to answer your question, Kaya, like it would depend on the use case, like in terms of from where, like what type of data needs to be accessed, right? Um, and they may be like to Nikhil's point, like we got to make sure that the data privacy and those type of aspects are taken care, because like say there's a certain clinical trial or research, it needs to go to like different systems to maybe check the historicals and also check like what's really going on with a specific like a user or specific person that we are trying to assess, right? There was one of the things we had done during our MIT class project, and that's where it was about the clinical trial data and how we could use that in order for us to say if we could find a match for the cure for that person. I'm not sure if this one kind of looks into that part of it, Nikhil, or it's a little different.
No, Ashish. So even in cases like that, right? When you use real world data in those kind of scenarios, most of the data needs to be anonymized as to respect the privacy of the
Right.
people who have undergone these things. And I think that's the uh, need of the hour, I would say, because trust is something that will always go a long way in taking a system from theory to adoption. And that's a very interesting discussion to have, I would say. And that's a very huge problem in the way AI works currently.
Yeah. And I think that's coming up a lot in the discussions also, like especially like there's a job market discussion going on, but then there's in general how much can we trust the computer systems and enterprises with our data, etc. So that has already been there, those discussions, and there are certain laws, etc. we got to follow, right? But I do agree, like we got to be able to design the systems in a way where the data privacy and these basic things which matter to the end user are definitely at the top priority.
Yeah. And like a leak in any kind of the systems is something, it would be a disaster, right? So I think that's an area of no compromise at all. I think that should be the founding pillar of any AI product that's going on, is that like the way the data is being handled. Because especially if the data consists of very confidential and private information.
Yeah, makes sense. Okay, anything else you wanted to ask on that question? Hopefully it answered.
Yeah, I did. I did. Yeah. Thank you.
Okay.
Yeah, I think we can go to the next slide. Oh, yeah, there is this one very interesting point in this slide, right? If we are using an AI assistant, if an AI assistant is requiring a reviewer before it can produce, like before the output can be used, right? We are just adding a new review layer on top of the existing one. And at that point, I don't think we are solving a problem, but rather we are creating a new one because the AI assistant's job is to make the search faster or the process faster. But if the reviewing layer takes up more time than that, then that's where fundamentally the system breaks down in terms of unit economics, right?
So basically, we are saying, like, is it the manual or the human layer you're talking about, or the AI layer itself for the reviewer?
So if our AI agent is not, if an AI outputs something, we are not yet at a stage where we can trust it completely, right? And that sort of creates another review layer where a human needs to manually check for the output an AI provides. So that is in itself is not a very optimal solution, considering that we use AI to reduce burden. But in this case, an AI is going to add burden to the reviewers, right?
Right, right. So how is like our project gonna kind of help us do that? Because you'll have the traceability to that, so it's kind of easier for the user to be able to make that decision easily.
Yes, and not only for the end user, I would say reviewing is a fundamental part. That part we cannot take away. But what can be done is that we can make the job easier for the reviewer. Like someone doesn't have to spend 2 hours manually checking everything. Instead of that, maybe they can spend 2 minutes saying, okay, this is where the AI got the information from. Let me check if this information is correct. Oh, it displays the information what it was there also. So that's how we step by step decrease the time needed for the reviewers as well. I think that's a real business pain point that I've seen people talk about.
Got it. Makes sense. Should I go to the next one, Nikhil?
Yes. So this one, right? This is uh, the part where engineers who build the systems face. Like people assume that better model is better output in many cases, which is quite not how it works because the bottleneck is not the quality of the output. The quality of the output is a factor, sure, but the quality of the output depends on what kind of retrieval is being done. Like, let's say, like the correct files are not being retrieved, but we have an excellent generation model. So the generation part gives out excellent answers, but it's just plain wrong. I think this is what engineers actually feel, and this is the problem that engineers face as well. I think we've spoken plenty about these points as well, so we
No,
can
no, I
move forward,
think
Akhish.
I hear you. It's the same thing, like the black box syndrome, right? So sometimes we may design this complex machine, but if we don't know how it's exactly working or giving the wrong result, it's kind of, I
Yeah,
think you're alluding to that.
yeah. And even most of the times, the citation is often, just for the sake of it and not really adding anything. It's just, uh, it's just there for the sake of it instead of it actually being meaningful. I think that's the problem engineers face a lot as well.
Got it.
Yeah, we can move to the next slide. Yeah, again, this is what we've been talking earlier. Like the retrieval part is like the actual problem here, not the generation part of it. Because I think AI models are now getting to a point where there's marginal difference in performance between the vendors, and that is starting to show, right? There's a minute improvements across different providers of AI services, but that part matters less, and the part that is more hard, becoming increasingly harder to implement is the retrieval part of the RAG pipeline. So this is the general uh, way that the products are facing and what engineering teams are trying to actively solve around here.
So, Nikhil, like when we talk about retrieval augmentation generation, right? So we
Mhm.
have like a LLM, and then we apply the RAG to it and gives you the result. So, like basically, what we are doing is like any LLM, like we are using that, and then we are supplementing it with this additional data, and then generating a better result for the end user, right? So, say for example, I'm using an OpenAI LLM on my data, then it gives me the relevant answer in context to my data. And so you are saying that how do we retrieve the data, say for example, from my drive or my data and make it relevant to me? Is that what you're saying is the difficult part?
Yeah, almost, right. But there's a small caveat to this, right? In medical or even legal data, for example, right? The way these AI systems are built, that is that they use something called as a term frequency. A small example is this. I know it's a little bit of tangent and going to get a technical, but a lot of these AI systems use something called term frequency. Now, what this term frequency does is that it checks the number of times a word is repeating in the document to assign a relevancy score to it. Now, for normal use cases, this might look good, but when we go through these legal and medical documents, they are very verbose documents. They have a lot of words and they are little difficult to comprehend. In that cases, what the model does is that it takes you know, these words and gives them unnecessarily high priority. And when the actual data needs to be fetched, these unnecessary keywords uh, become a pain and slow down the performance of the model.
Okay, got it. So probably you have more details on that, so I won't go further into it. But what else we want to cover here, Nikhil?
Yeah, I think I've covered everything. Even like the product quality always lies in the evidence layer. So this is the kind of a high level architecture of how Project Apollo was envisioned. So we have a clinical corpus and we have the secure layer where we pull data from sources, we mask the data, we use the data, and then we discard the data. And then we have our evidence and the hybrid retrieval for it. So this is a high level solution architecture of what Project Apollo is supposed to be. I think we can go to the next slide. Yeah. So this is what I was talking when I say, it doesn't have to just be the source document. The source document is just the step one of an evidence first model. Even in the source document, on which section is the source being coming from, and a citation card, which helps the reviewer understand what kind of the claim linking is being done here. Uh, Anyone have any thoughts on this part?
Let me just see this. So we have clinical corpus, secure layer, evidence, hybrid retrieval. So basically, like these are the way the main data is coming from the clinical corpus, and then it's kind of going and comparing the data against some of your database. Is that how this is structured, Nikhil? If you can break it down a little bit more.
Yeah. So, for example, I'm pulling data from this site called AICTE, right? Like the government American clinical trial data. They have an API endpoint through which they expose declassified data. For example, if I am pulling the data in, so the first part of the corpus would be to actually break down the data itself before it goes into processing even. There is some level of processing that is done here. It uses some keywords to segment what kind of a clinical trial this is and in what category it belongs to. This is sort of like assigning hashtags to a post, right? So that we can know, okay, when we press this hashtag, these kinds of posts come up on our feed in our social media. So
So
this
your
is very similar to that.
so your API that you're talking about is this one API.
No, no, the API is given to us by the provider from where we are getting the data. The processing part is what makes this clinical corpus.
Okay, ultimately, okay, got it.
Yeah.
And the like the end result of this, the RAG, like evidence-based, like retrieval augmentation, right? So basically, you're able to, when you're doing the clinical corpus, then you're able to cite like from where you got that. That's the end result. But then you're able to say, hey, this is where I got it from the API.
Yes, this is where I got the data from, and
Okay.
it was at this date that I got the document, and
Okay.
it was from this source, like down to the last
Okay.
level of possible detail.
So basically, the hybrid retrieval, this is where you're getting the data. It's kind of going through these.
No, no, it's the other way around, Ashish.
Or you're getting the data here and then is going to hybrid retrieval.
Yeah,
Okay. Okay, I'll do an offline more. I think probably I'm still trying to figure that out. We can discuss that more offline.
yeah,
Okay.
and yeah, this is the data model for the project Apollo, right? We don't just cite the source document. We specifically search from where in the document was the data retrieved, and then we present that information cleanly to a reviewer as well, so that people can trust the data.
Yeah, I think this makes sense to me. Like basically it's more like connecting the dots between from where the data came, right?
Yes.
Okay.
And this is more on the retrieval philosophy, right? Uh, of- this is what I talked about when I was giving the hashtags example, right? Is that the contextual prioritization is where I rank the candidates based on this hashtag sort of a system that I told you, right? So that is where the relevance is ranked basically. And then from the key query, like the question that is put to the LLM, it finds this in the discovery phase, it finds this term across the entire data, and then it only keeps the evidence where it can confidently say, okay, hey, this is where I'm going to get my answer from. And if it cannot do that, it immediately rejects it. That's the core working of the retrieval pipeline, I would say.
So just to contextualize it a bit more, Nikhil, so like the use case that we have is there is like clinical data that's available to us. And then
Mhm.
what kind of a search are we doing in the database to retrieve this data and bring it back to then say, hey, this is the evidence for this particular use case. Can you say, like, share that example?
Yeah, so imagine we have a clinical trial for a COVID vaccine trial, right? So we have a lot and lots of trials, maybe hundreds of thousands of trials. And then we want to see how does this affect people which are in the age group of, let's say, 6 to 8, children between 6 to 8 years. So what Apollo does is it firstly it tries to find out the keywords from it. COVID, 6 to 8, these kind of things it prioritizes. And then across the entire corpus of the data that we have, it finds out, okay, this is these are the clinical trials where children this old were actually the vaccine was tested on. And then in the supportability section, it checks, okay, does this evidence support the claim that I'm going to make? Or if the
Okay,
evidence is sufficient, it goes. If it's not, it just rejects it.
got it, got it. So it makes sense. So there's this humongous amount of data, which is like the actual users who are using the COVID vaccine. And then you're kind of checking those results of how the vaccine acted on that. And then you have like the computer system where that information is being fed in to say like where it was like basically successful or not successful, right? Is that
Yes,
the right way to think about it? And then there are these hashtags and all basically showing, hey, oh, this is COVID related test, or this is related to like a successful test or not a successful. Those hashtags and things like that are helping you make that happen.
yes. They make the process faster. Yes.
Okay.
Yeah.
And now
And
just a sec. So when
yeah.
we say in this part, clinical corpus
Mhm.
is the part of the data that you're retrieving about the tests, about the people who have used that, or is the hybrid retrieval part of that?
No, no. A hybrid retrieval is when the question is asked to the model. It already has the data. It has the relevant data sorted for it. Hybrid retrieval is when it does this thing where it basically does two kinds of retrieval. One is called a sparse and a dense retrieval. It does a mix of both of these and then tries to come up with, hey, is this piece of data relevant to answering the query or is it not?
Okay.
Yeah.
Okay, just trying to relate the business problem to that. Okay, anything more here, Nikhil?
No, this is quite good as is. Yeah, I mean, this part is, one of the more famous things that I keep hearing about is that just using vector search is it's never enough, right? Any like people who usually say that using vector search is enough are right when that it's the right tool to use, but not in case of uh, like this verbose data, like the legal or the clinical data, right? Because it has to be very precise, and that kind of precision is just not possible with a vanilla vector search.
So can you break down a little bit more about what is the difference of the vector search versus the other search you're talking about? Because I've heard of like the vector databases, and especially in case of like images, etc., we got to use vector databases. Is that a similar context or?
Yeah, so the way vector databases work, right? To give you an example, uh, we have two words. Let's just say the English dictionary is our corpus of data, and every word in the dictionary is a data point for us. So every data point is mathematically stored as a vector. And when these vectors are stored in this way, there are similarity scores assigned to two different words, right? For example, there's the word king and then there's the word queen. Since both of these words refer to the royalty, they are, bundled closely together in the vector database because they refer to the same sort of nobility, right? The nobility class. So that's where the vector search works. And that is fine for most use cases. But in medical cases, what happens is that let's say we have something called hypertension and hypotension. The word tension is still the same and it still refers to a medical condition, but these are completely opposite terms. So these cannot be stored in a similar ranking, right? So that's where the hybrid approach works better than just using a plain vector search.
Okay, so what would the hybrid be like vector plus what?
It would be a vector-based search, like what it does semantically searching for the similar chunk, but it also needs to have some sort of exact matching score. Like, hey, is this 99.9999% accurate to what the user has actually asked for? So it needs to be able to distinguish the similarity from the evidence. Like, hey, this looks close enough. It's not going to cut it. It needs to auto reject it. It should be exact.
Okay, so in Project Apollo, basically you try to use both these techniques.
Yes, it's a hybrid of the vector search and term matching. And there's also a multi-stage ranking algorithm, but that's a whole topic in itself, right?
Yeah, I think we can take that up some other time.
Yeah. So, yeah, this is how the workflow goes. User asks something, the evidence is retrieved, the evidence is selected, answer is drafted, and the support validation is done.
Okay.
Uh,
So basically, the user's asking, hey, how was the COVID result, test, vaccine result on ages 30 to 40? So then it goes and checks basically like how it, like based on those things that you explained, like the hashtags, etc., and the data itself, the API query
mm,
that you talked about, right, is kind of coming from some other database with proper anonymizations, etc. Then it
mm.
selects the evidence and gives you the answer based on your models, etc. that's there.
Yes.
But what kind of model you have used, Nikhil, in the background? Like, can you give us a breakdown of that?
Yeah, so initially I started off with the GPT OSS models, but during the middle of the project, right, Google has just announced the Gamma 4 models, and these models made much more sense to me to use because of their insane ability to perform in very small constraint systems. where there's not a lot of need for virtual RAM or the GPU processing power. So
Hmm.
right now it's Gamma 4, but as the model comes, like better models keep coming along, right? I think it's
Hmm.
always a good idea to have a hot swappable model.
So your use case is more for the researchers and the scientists who are working on their own like limited space, or is it more for some other type of like a large scale computer systems, etc.?
So this is more for tailored towards people on their personal machines, right? Because not everybody has access to enterprise compute power. Like the hundreds and hundreds of GB of RAM is not something everyday people have access to. So Project Apollo aims to keep it reasonable because machine learning fundamentally requires a lot of compute power. We cannot take that away. But what we can do is we can come as close as we can to doing it on our local machine.
Hmm. No,
Mhm.
that's really important because I don't know if that's really kind of like is one of the ideas, right? When we were doing the MIT course, there was a talk about there's so much of energy consumption happening into AI. So if there are some of the things can be solved with some better thinking in terms of how we can use less of that and do it locally, maybe with less of more efficient models, etc. I think that kind of connects the dots there, but maybe everything is not possible to be done that way.
No, actually, I think we are getting there slowly, but yeah, it's a long road ahead, but we are making progress in the right direction, I feel on that one.
Nice. We are making a dent in the universe.
Not me, but there are much bigger players than me, right, making this kind of optimizations.
No, nice, Nikhil. Really great. So anything else here, or should we go to the next?
Anybody else has any questions? I think we can go to the next slide.
Yeah, Nikhil, sorry, I just wanted to ask that evidence, right? In what format is that visible for the user?
So yeah, so let's just say I have a document which talks about the clinical data for 6 to 8 year olds, right? Now the user query is something about 6 to 8 year olds with a specific condition. Now the system not only has to retrieve the document, it also needs to specifically back up the claim with, hey, this specific condition was mentioned here, and this specific condition ties into this part of the clinical trial. That is the kind of, transparency in the output that we need from these systems.
Okay, makes sense.
Yeah. And this one, right? This one I feel is like a very important part because people shy away, right, from telling, I don't know. Even as we as humans have this tendency to say, okay, maybe I don't know. But in matters of life and death, right? I think mm, having the ability to say that, okay, information is insufficient is always better than confidently going with the wrong information. I think that's where the trust part of it comes in. I mean, we try to make sure that it gets as robust of an answer as it can, but it should also be able to refuse to give an answer when there is insufficient evidence, right? So this is one of the core features of Project Apollo.
Nice.
Yeah, we can go to that. Yeah, this is what we were talking about, Ashish, like the local first and the enterprise aware deployment, right? So again, the workplace constraint is something that we always need to keep an eye on, especially with the power consumption that you were discussing earlier, right? So cloud infrastructure and the local, it should be a hybrid mix of it. Like the tasks that are strictly, require a lot of compute and repeatable kind of a task can be done and the data can be kept in the cloud. But for the actual, architecture, like the deployment path for the models should always be in the local, is what the Project Apollo strives to be.
No, that's really nice. I think you're kind of, it's a very good refresher for me, at least to remind me of all the details. And you are doing this on a daily basis. So it's super exciting stuff here, Nikhil. I mean, really great. Thanks for answering our questions and everything. Do we have more slides here, Nikhil, to cover?
No, I think this is it. Yeah, this is the evaluation part of it. Like how good is good enough? This basically answers the question, how good is good enough, right? So these are the four steps that Project Apollo does it this way, not necessarily, you know, in the order, but these four steps are done. So the first thing is that the quality of the data is measured, okay? So it pulled out a document. Is the document coming from a valid source, or can it be traced back to a clean, verifiable source? And next one is that it is making a citation from a document. It also needs to answer that, okay, is it accurate? Is what I'm citing accurate or not? And that's one thing. And unsupported answer behavior is more of a security concern, because AI models by themselves are very capable, right? So even if I build it for this specific use case, someone can come in and say, hey, what is the answer to 2 plus 2? Now the model can say 5 very easily, but that's not the intended purpose of the system, right? So in that cases, the system should have guardrails to prevent this kind of abuse of the compute power.
No, that's really cool. I think in terms of like, whatever you have achieved here, Nikhil, is really amazing. I feel like it's not an easy feat. Like in such a short time, you've turned around so many amazing things and also very patiently educated all of us. I'm sure people would have got a lot out of it. And definitely for our audience, I mean, you can definitely like contact us at katbots.com/contact us. We look forward to hearing your thoughts on this topic. Please let us know. And in the future, Nikhil would be kind enough to do a demo for us. We look forward to that.
Yeah,
That
yeah,
would be
looking
amazing.
forward to that.
Any closing thoughts here, Nikhil or Kea, Karthik, anything you guys want to add?
I think this was an amazing presentation, Nikhil, and the core of, because everyone is building AI, but this is something different and can make a big difference in the industry. So I'm looking forward for it.
Yeah, thank you for the kind words.
Great. No, really amazing. Anything, Karthik, you want to add?
And also, one thing that literally stood out for me was like, you're treating this project Apollo as a feature. I mean, the refusal part of it as a feature, so which is very rare. So usually for AI, if it doesn't give you answers, so nobody's going to use it, right? But if it is wrong, it is wrong. So you're showcasing it as a feature, which is actually a good thing. So yeah, that stood out for me.
Yeah, I mean, it's the same philosophy, right? If I go to the doctor and the doctor doesn't know what disease it is, he says, "Hey, go to a specialist instead of diagnosing me wrongly." I think that principle applies to my AI as well. Like that's how I like to think about it. But yeah,
So it's
That's very
Doctor
cool.
AI then.
That's very cool. Just for see, I'm sure the audience have loved this presentation and learned a lot. Nikhil, thank you so much for this. And for the audience, right, we'll continue to bring more interesting topics to you all. And thanks, Kea and Karthik, for being here. And Nikhil, we look forward to your next presentation. And for the audience, just want to kind of share a disclaimer. We missed it at the beginning, so you guys can go through that. And then also we have like this disclaimer is on our website as well. And anything else, guys, before we say bye to everyone?
I
uh,
think,
I think, yes, please go and follow our channel and subscribe.
yeah, please subscribe.
yeah.